other cassette motor. I was explaining in the previous live stream. I put it in, but it's bracket to hold it down. But I stuck some blue tack on the table there, stop it the motor from moving out of position because I don't want to get the belt out of alignment. Now, I've connected it up. I haven't changed anything else. All the diodes, LEDs, and everything else, and the output LED. But look at the RPM. It's gone up. Under load, it's actually gone up to 1120 instead of about 1000. Also, the input current has gone down. So we're now about 105. Maybe it's still climbing. I mean, it's currently milliamps instead of 120 milliamps, because the previous test it was over 120 milliamps. Now it's below 110. So we've gained RPM. I'm on the same voltage. I haven't changed the voltage. We're still at 9 volts. Let's have a quick look. So we're still at 9 volts on the DC, right? So it's brilliant. Oh, hang on. Let's have a look. Yeah, it's still dropping. So we've gained RPM. As I predicted, I did need to increase because this motor's not as high a RPM as the other motor. It's got more torque but less speed. I had to gear ratio it onto the outside pulley. Yeah, I can't think of the word right now. So it's on the outside pulley now, because anyway, you can see for yourself. I mean, it's much better. It's a benefit. I mean, the CD motor like this one here, which is in there, I've still got it fitted, so if I need to swap it over again to compare it. So it's fairly easy to swap the power from there to there, but I have to obviously move the drive belt, which is you can't really do that easily when it's running. So yeah, it's not easy to swap from one to the other when it's running. So if I could find another belt, or that elastic band or something, then that would. You can't really do either, because that motor would become a drag. It would become a brake, so it would slow it down. So yeah, but anyway, doing tests. I want to give you a quick update to this on Sunday, and I think it's the 10th of July today. Anyway, I'm really chuffed with the result. I mean, it's a positive gain. I mean, the fact that we've got more torque, and I haven't even changed the voltage. Remember, this motor runs at a higher voltage. It's supposed to run about 12 volts, but we're still running it at 9 volts, right? So in theory, I could step the voltage up to 12 volts, and the current would probably drop even more. Well, it wouldn't go up anymore, but it would gain even more RPM and more efficiency. So what I'm leaning towards at the moment is the fact that it seems like the higher the voltage, let's face it, voltage isn't a huge loss compared to current. So it seems to me that the higher the voltage of the motor, the more efficient it is when you're driving it. So using a high voltage motor translates to lower current consumption. Obviously it's all about watts, I know. It's really, the bottom line is watts, but I haven't got anything measuring watts on this, so I can't really tell you right now. I've got this thing in the bedroom, which is ridiculous, because it goes in increments of 0.10 milliamps, so it's just not very accurate, so I'm not using that yet. But maybe sometime I'll make a module and so I can compare input watts versus output watts. I'll do that at some point, but I'm not going to do that until I get close. I mean, once we get to a point where I can actually run this thing can power itself, because all these LEDs are consuming power, so you can't really see it with a big light on. It's a bit bright, so if I stand in the shadow you can see that all my LEDs are lit. Let's see if this one's coming on. This one's just coming on, but that's got these LEDs across it, so it's pulling them down. But yeah, we are definitely making improvements. So there's my new motor mount with the pliers resting on it. You see the belts creeping towards the edge of the pulley. Well, that's why I've got the pliers on, to hold it down so it doesn't, this thing that sticks out is soft still, because I only printed it yesterday and I acetone treated it, and it's a bit soft, and I don't want to bend it because then this thing will become deformed and then I won't be able to get it back. So what I'm trying to do is, I just wanted to do a quick test. I'm just eager. So when I end this live stream, I'm just going to turn it off and let that thing harden for a couple of days before we run it again. So anyway, at least you can see what's going on. Something like that. You can see that we're making some more positive head progress. Yeah, on my truck. I haven't changed any of that or anything else. Oh, my resistor's falling off because I knocked it earlier. Oh, it's this wire that's caught in it. So, oh, right, anyway, it'll be alright. So anyway, well, we're definitely gaining, because, I mean, it was running below around 1,000 RPM with all these LEDs on before. So, yeah. Anyway, thanks for watching. Take care. Bye for now. Oh, the oscilloscope. I almost forgot. Yeah. Just before I go, there's the oscilloscope readings. The yellow channel is the small coil. The blue channel is the big coil. Big coils, I mean. But remember, there's a load on there. So anyway, there's the oscilloscope. Right, okay, bye for now.